All right, sixth graders, we are actually skipping ahead to the very last chapter in the eighth grade book. Chapter 10 covers exponents and scientific notation. Now, exponents, you will hear me a lot more in junior high than elementary school. You'll hear me a lot more saying powers. So power and exponent are interchangeable. So they technically are the same thing. So exponents, section 10.1. We have three vocab words, all of which I'm certain you've heard in some context before. A power is a product of repeated factors. The base of a power is the common factor, and the exponent of a power indicates the number of times the base is used as a factor. So let's do an example, or let me just show you how this looks. If I gave you the factor 1/2, that is called the base. If I take it to the 5th power, that is called the exponent. This right here is called power. 1/2 to the power of 5. What that means is you are going to take 1/2 times itself, a repeated factor, you're going to times itself 5 times. So what that means is 1/2 is used as a factor 5 times. Example number 1. Write each product using exponents. You got to be careful what it's asking you here. It is not asking you to take -7 times itself 3 times. It's saying write it as a repeated power. So -7 in parentheses to the 3rd power is your answer. In part B, it says pi times pi. Pi times pi is pi squared because you have 2 of them. And r times itself 3 times gives you r to the 3rd. Now you're going to notice a lot of what we're doing today, you're probably thinking, we've done this. You're right. That's why we're skipping from 7th to 8th grade, because all of the stuff we've been doing flows together. So right now, we're going into exponents. You're going to start learning rules of exponents that you have not learned before. Example number 2. A and B, evaluate each expression. A is -2 in parentheses to the power of 4, and B is -2 to the 4th power, or -2 without parentheses to the exponent of 4. -2 to the 4th power would give you what? Positive 16. B, -2 to the 4th power would give you what? Negative 16. Why? Because in A, you are taking the negative to the 4th power as well. In part B, you are not. So we're going to go to some harder problems. C. 3 to the 3rd power minus 8 squared divided by 2. I mean, this is just simple order of operations. So 3 to the 3rd power, 27, minus, we're not taking the negative squared, so this is minus 64 divided by 2. Obviously, we follow order of operations, so 27 minus 32 will give me an answer of -5. Should be fairly easy. Letter D. The absolute value of -3 to the 3rd power divided by 27. The first step is taking -3 to the 3rd power, which will give you -27, divided by 27, which gives you -1, and the absolute value of -1 would give you +1. In example 3, we're going to talk about a real-life application on page 413. In sphering, now if you don't know what that is, if you're looking at this, it's kind of hard to see, but this is when a person can get inside of a ball and roll down a hill. In sphering, a person is secured inside a small hollow sphere that is surrounded by a larger sphere. The space between the spheres is inflated with air. What is the volume of the inflated space? Well, what do we know? The only thing we know is that the diameter of the small sphere is 2 meters, and of the larger sphere is 3 meters. So the first thing we have to do is realize we have to find the radius. So of each shape, so we're going to do outer sphere and inner sphere because we have 2 spheres. And if we want the volume of the inflated space, that's this area, if you can see it, around the outside. So we have to take the bigger sphere, the outer one, and subtract it by the inner sphere. Now, we probably have, well, I know we haven't gone over it, but you may have done this in the past, but I doubt it. The volume of a sphere is 4/3 pi r cubed. So we're going to use that for both shapes because they're both spheres. Volume equals 4/3. We are not going to plug in 3.14 for pi because I'll show you at the end what we can do. The radius. Well, the radius is half the diameter. The diameter of the big sphere is 3, so we can write it as 3/2 cubed. V equals, remember, we can do this smartly. We don't have to get decimals here. 3 to the 3rd power is 27. 2 to the 3rd power is 8. I now can multiply, but simplify first. 3 goes into 3 once. 3 goes into 27 9 times. That gives me 9/2 pi. There was no need to use a calculator on any of this, and we didn't have to get decimals. The volume of the inner sphere, 4/3 times pi times radius cubed. Well, the radius here is 1, since that's half the diameter of 2. 1 to the 3rd power is just 1, so that's going to give us 4/3 pi. Now we have to subtract them. 9/2 pi minus 4/3 pi. Well, we can get a common denominator here. That gives me times 3, 27/6 minus 8/6. So 27/6 minus 8/6 gives me 19/6 pi. So that would be the volume of the inner sphere. Now you're like, wait a minute, that doesn't make sense. You can always take 19 divided by 6 times 3.14, and it will give you approximately 10 cubic meters. And we always need to remember that label. Now, I want you on your own to do the exact same problem, but instead of the inner diameter being 2 meters, it's going to be 1.8. So now what would be the volume of the inflated space? Pause the video and do it yourself. If you actually figured it out, the inner sphere, and subtract it from the outer sphere, you would get approximately 11.1 or 11.08 cubic meters.